All right, in this second example, I will show you how to factor the quadratic form, a polynomial that is in quadratic form. Okay, here is an example of a polynomial in the quadratic form. Okay, so I have 4x squared 10 plus 10x minus 6. I know it's in quadratic form because the first term here is a perfect square that can be written in another form. Okay, so let me show you what I mean by perfect square that can be written in another form. So if I have 4x squared, well, let's go back to quadratic form. The quadratic form looks like this: x squared plus bx plus c. Granted, there's no leading coefficient. Okay, so if I have something that's given to me that is not in this form, I can actually change it to look like this. Okay, so let me write this one next to it. 10x minus 6. I need to rewrite this so that it's just something squared. Let me put a parenthesis there. So I need to rewrite this so that it's something, this quantity is going to be one quantity that is squared. Okay, and then with plus something that is the same quantity here that I square here, I'm going to put in the second parenthesis and then minus 6. I want something like that. So it's easy to determine what to put inside the parentheses. Okay, all I need to do is to look for what am I going to multiply by itself to give me 4. The answer is 2. What am I going to multiply by itself to give me x squared? That will be x. So if I do 2x squared, I will get 4x squared. Now remember that I have to use the same quantity inside this parenthesis as my x. I'm just replacing x with that quantity, so I'm going to use 2x over here. But if I compare that to my original coefficient, I see that I needed 10, but I have 2. So what times 2 makes 10? That will be 5. I need to put a 5 there so that I don't lose anything. Okay, so I have almost set up everything now, except that I just need to write it over here. So it will be 2x to the power of 2 plus 5 2x minus 6. Okay, so I think this might be confusing a little bit at first, but it's actually a very interesting thing to do. So let's say I give you another one, like I'm going to continue this problem in a moment. Okay, so let's say I have another one like a 9x squared at the beginning. I know that this is going to be a quadratic form because that's a flag for me. If I have a perfect square at the beginning, I know that's going to be a quadratic form. So it's going to look something like this, squared, and then plus something with the same thing here, and then let's just make something up here. So let's say it's minus 15x plus 8. Okay, so, well, I want something that I'm going to square that will give me 9x squared. Okay, I just know 3 times 3 is 9, x times 6, x is x squared. Okay, the thing is that I got to use the same 3x somewhere over here. I got to use this as part of my b, okay, because x is part of the b. So I got to put 3x here as well. So 3 times what makes 15? That's 5, okay, if I keep the sign the same like plus over here. Okay, so that's the gist. The c, I don't touch it. It's the a and b that I manipulate. I just manipulate those to fit my my what I wanted. Okay, here's another one, like maybe it's that's another one. Let's say I'm given 64x squared, minus 24x plus 10. I can write this in quadratic form like this. So I need something multiplied by itself to give me 64. That will be 8. And then something multiplied by itself to give me x squared. That's x. So that's what I'm going to square. But remember now, because I already have this x replacing, this 8x replacing x, I must replace x here also by 8x. So 8 times something will give me 24. I want 8 times something to give me, that will be 3. Because 3 times 8 is 24. And the c time I don't touch. So I have taken time to explain to you how to change any problem now to quadratic form. So that's what we have just done in example 1. The next step is to let whatever that is in this parenthesis, this stuff over here and this stuff, I want it to be a letter, another variable. I like u because you're going to see u again later on in calculus. Okay, so we're going to let 2x be u. All right. So now we can rewrite this equation now as u squared plus 5u minus 6. See, the goal is to get it back to a very easy and simple equation to expression to factor. This is a very easy trinomial to factor, like I showed in the first video. Okay, so let's just factor it. So I want -6, so that's -6. I want 5, so 1 and 6. I don't need to look further. I just need to change the sign of one of them, so it'll be -1 and 6. And I got it. So it will be u minus 1, all right, and then u plus 6, all right. We got it. Now, but we're not done because we are given our original problem was not in terms of u, was in terms of x. So we need to go back and replace that u with 2x. So we're going to go back and replace the u with 2x. So everywhere we see u, we put 2x. So it will be 2x minus 1 and then 2x plus 6. I just went back and replaced the u with x. We are basically done, but if you say to factor completely, well, we can take one more step further. We see that 6 and 2, there's a common factor there. See this, let me highlight it. This 2x plus 6 can be factored more. So we can just take out a 2 there. So we have 2x minus 1. And then it's a 2 that's common there. So it will be x plus 3. Now we can put the 2 in the front, like 2x minus 1 and then x plus 3 because of the associative property of multiplication. So we can just rewrite them in any order we want. That's basically it. We're done. All right. So I think I would like to do one more example that look like that. Let me look up an example I can do that look just like that. So let's say I have example 2. I have 36. Oops, 36 is what I wanted. 36x squared. All right. Plus 78x. Not writing very well. Okay, 78x. And then plus 42. All right. So we're going to write it in quadratic form. Okay, so we're going to start with what we multiply by itself to give me 36. That will be 6, and that will be x. All right, and then 6x squared. That is easy. We go over here, we put the 6x over here. We need 6 times something that will give me 78. If you take your calculator and do 78 divided by 6, 78 divided by 6, I'm trying to do it over here, you will get 13. So you get 13 here, and then plus 42, I think it was, plus 42, okay? Just confirming over here from my problem, original problem. Okay, so that's what I wanted. So now we can replace 6s with u. So let's say let 6x equals u. That's the u sub there. Okay, so we do u squared plus 13u, all right, plus 42. Okay, so now we got it down to the very easy trinomial. So what we do is to try to break 42 up. Well, looking at that 13, I just know I need to use 6 and 7. They are both positive. So u plus 6 and u plus 7 is what I needed. And now I can just go ahead and replace the 6x back again. So it will be 6x in place of u. and then 6x plus 7. Well, I can take out a 6 here, so it'll be a 6x plus 1 and then 6x plus 7. All right. That's basically the answer to this problem. All right, I have another quadratic form down here, which I'm going to call example 3 now. So this example 3 coming up. Here is another quadratic form, okay? Well, you can see that the job is done for us already. You can just look at the structure. You can see that this is being squared. That's like a x squared or u squared. And that's like my u, okay, already. So this one is done, almost done. We just need to we're going to let s squared minus 9x to be u. And then we're going to have u squared minus 2u minus 80. Okay, so to do this, we just do the easy factoring. So negative 80. Well, I'm looking for a number that will multiply to be, two numbers that will multiply to be 80 and that will add up to be negative 2. Well, obviously 10 times 8 is 80, so 10 and 8. But I want a negative 2. I want a negative 2, so I have to use negative with the 10. So it will be u minus 10 and then u plus 8. So now our job is to go back and replace the u with s squared minus 9, the original. You see, this was our u. Always go back and replace it. So let's do that quickly. So we're going to do s squared minus 9x. That's the u, okay? Then don't forget this negative 10, minus 10. Okay, we've done the first binomial. We go to the second one. So s squared minus 9x, and then don't forget the 8, plus 8. And now we can actually factor one more time. We see easy trinomial here. So this is negative 10, and we break it into 2. So 10 and 1 will give me negative 10, but I need a negative 9, so I put negative 10. So this one will be x minus 10, and then x plus 1. Okay, we've done that. And then we do the second one. I want 8, so this is 8, and I want 9, so I need 8 and 1, but both have to be negative to get negative 9. So x minus 8 and x minus 1. And basically, the original expression now is this. This is the factor, the final answer to the factor. Okay, so the last example is coming up, which is going to be example 4, really, not 3. So I needed to give you more example with this because it's a new material. All right, so you can see it's almost done for us as well. Only we have to recognize that here, we need to write this as something squared, and then something, the same thing, okay, and then minus 24. All right, so we have x to the 4th. What am I going to multiply by itself to get x to the 4? Well, you know, x squared times s squared will give me x to the 4th. So I need to put s squared here. All right. Whatever I use with the parentheses here, I must use over here as well, okay? So the second one is almost done. What am I going to multiply by s squared to give me 5x squared? It's just 5, okay? And those are the only two things, the only two terms that we mess around with. So we're going to let u equals x squared. And so we're just going to replace that with u squared minus 5u minus 24. And then do the easy trinomial, 24. I want 5, so I need 8 and 3 to get 5. So I need negative 8 and plus 3. So it will be u minus 8 times u plus 3. And then we're going to go back and replace the u with x squared now. So it will be x squared minus 8 and then s squared plus 3. This is the answer to the original problem. It's the same. We just factor it. Well, I hope this long video will help you. You can pause it and rewind it and do which part that you might be confused with. All right, that's the end of the factoring in the quadratic form.